Assalamualaikum warahmatullahi wabarakatuh and good afternoon. My name is Ihsan Yassin. Um, Together with my co-researchers, I would like to present our project entitled Artificial Intelligence Persian Carpet Design Synthesizer. This project is um, a collaboration between three universities and one collaborator from industry. The first collaborator is from MRI or Microwave Research Institute, UITM. The second one is from UMP, University Malaysia Pahang. The third university collaborator is from Alami University in Iran. And the final collaborator is from the industry, which has been kind enough to help us with the data set for our project. A little bit on the problem statement before we continue. The Persian carpets are a huge export. They are originally from Iran, and these carpets are renowned for their elaborate and intricate designs. The current method for designing Persian carpets rely heavily on human expertise. And this poses some limitations in terms of time, where it takes a lot of time to design those kinds of carpets. It also requires a significant level of skill and experience. And if you have one designer, the variations of the design is limited to that particular person. So in order to solve this issue, we present our project, which utilizes a very new discovery in the field of artificial intelligence or AI, called the Generative Adversarial Network, or in short, GAN. In this project, we are using GAN to generate the Persian carpet designs automatically using a computer based on real-life examples of Persian carpets. So as I mentioned previously, we are doing this collaboration with Beheshti Carpets in Iran and also Alameh University. The proposed solution would help to improve the design process, as using computers, a variety of designs can be generated relatively quickly and effortlessly. And another good thing about this is that the GAN learns from examples which comes from various designers in Iran. And using these designs, we can encapsulate and embed the years of experience into the computer so that it can design based on a wide spectrum of skills of Persian carpet designers. This is a bit on the concept of GAN, where the generative adversarial network contains two competing neural networks. For those of you who are not familiar, neural networks are a very special type of computer program that allows the machine to the computer to learn based on examples. So for GAN, there are two competing neural networks. The first neural network is called the generator network, and the second network is called the discriminator network. So the generator network is responsible to generate artificial images, fake images, when given a noise vector. This noise vector can be anything. Basically, the generator network needs an input, so we give it a noise, a random number, and based on this random number, it learns to generate fake images. Those fake images are then compared to the real images collected by us. And the second network, called the discriminator, is responsible for deciding whether an image is real or is it a fake. So during training is where we improve both neural networks at the same time, both the generator and also the discriminator. The discriminator gets better at recognizing fakes, while the generator gets better at producing fakes. And this goes on for a very long time. And after a certain amount of time, the generator becomes so good that the discriminator is unable to determine whether at any time a given image is either real or not. So after this, we remove the discriminator network, and we are left with the generator, which can generate as many samples as we want. And these samples are almost undiscernible from the original. Okay. So in our experiments, true enough, when we conducted this experiment, this project, the images produced by the generator was quite well designed, in a sense that it has symmetry, it has color, and it has a lot of variations that are also present in the original images. So for our project, sample images were collected from Beheshti carpet in Iran, and several thousand other images from stock photo websites, such as Pexels, and some other websites. And we use the lightweight GAN architecture, which is available here in GitHub, to be used as the platform for training. The code was done in Python, and after training, the samples were generated to verify the results. Here we can see the training progression. Initially, what we can see is that at 0 iteration, we can see that there's not so much resemblance to a carpet. So in the initial stages, what we would expect is that the discriminator can quickly throw away the samples generated from the generator. However, as you can see, as the training progresses, the carpet designs are looking more and more realistic. Okay, in some cases, as you can see here, there's even in the 100,000 iteration, there's even some form of symmetry and color involved in the generation process. And as training progressed, we saw more and more symmetrical and better designs. Up until this stage, we're at 300,000 iterations. This took around 1 to 2 weeks to complete. And once we have the around 30,000 iterations, we see that we saw that some samples generated using the gun were of sufficiently high quality. And the final results are shown here, where these are all samples, some of the samples generated using the gun. As you can see, there is a spectrum of colors and shapes and sizes in the gun process. However, these images are somewhat low resolution. We are hoping to use a higher resolution. However, the computational limitations of the project made us reduce the resolution a bit, and it produced somewhat like something like this. Maybe in our future work we will try to improve this aspect. This neural network, this gun neural network, if you can look over the internet for some literature, it seems that it uses so much computing power, and it requires the use of a GPU, or graphics processing unit. Even then, with a computer from for our project using 4 GPUs, it really took a long time, close to 2 weeks, in order to generate these kinds of samples. Okay, so that's about it. I hope you can consider nominating this project for an award in the competition. Thank you very much. Assalamu.